Hi guys, in this video today we're going to be talking about Euler's number E. You've already watched a couple videos that give you some background into E, and then today we're going to talk about how to graph with E and how to do calculations with E. So you will need your graphing calculator. Can you find your graphing calculator? Because I'm going to show you some things on that calculator. On your graphing calculator, over by the 4 button, there is an LN button. We're going to use that LN button next week. Above the LN button, there's this E to the X button. That's the button that we need to pay attention to. So I'm going to go to second, E to the X, and it automatically puts a power in there. I want to find out for my paper right now, I want to find out what is E to the first power, enter, and it's 2.718. We investigated that a little bit in the notes the other day. I can also do E to the negative 1 because I know in my paper that's the next thing I want to do. So if I go to second, and that ln right at the 4, the e to the x is there with it, and type in a negative 1, enter, then e to the negative 1 is 3.6789, blah, blah, blah. Okay, let's go back to our paper. From our calculator just a second ago, we got that e is 2.718, and e to the negative 1 is 0.368. Now, you do not have to memorize those because your calculator will give them to you. However, 2.718, I feel like it's a good one, even though you're not technically memorizing it, a good one to have in your head, because as we do graphing, we're going to be estimating 2.718 on our graphs. And so on my graph, on my y-axis, I'm counting up to 3 because 2.718 is awfully close to 3. So that's how I'm going to set up my graph. Now remember from the other day that when we graph exponential growth, because this is exponential growth, the only difference is it's an exponent, but it's base of e. And so when we graph it, the first point is still 0, 1, just like it always is. My next point to the right is going to be 1e. So I'm going to go over 1 and I'm going to go up to 2.718. Okay, because remember that's how we were graphing exponential functions before. And the negative 1 is going to be 1 over e, which is 0.368. And so that's going to be the graph of e to the x power. It is an exponential graph. Its kind of middle point, whatever, is 0, 1, just like all exponential graphs have a point there. Our next point is 1e, because that's how it is always on the base. In other words, let me just remind you that if this was 2 to the x, then my next point would be 1, 2. But here it's e to the x, so it's 1e. Okay, e to the negative x is going to follow the pattern that all of the exponential decay. Well, first of all, the negative power means decay. Anytime you see that if the base is a whole number, or a number greater than 1, and the exponent is a negative number, that's going to be decay. And so it still is going to have a point at 0, 1. It always does. Because the reason, remember for that, the reason is if I plug in a 0, anything to the 0 power is 1. Over here, anything to the 0 power is 1. And so that's always a point. My next point is going to be to the left is going to be negative 1e. And to the right is going to be 1 and then 1 over e. And so it's going to look like this. You just need to have a general idea of how those look, and those 3 points, which we focused on those 3 points a couple days ago in our video also, those are the 3 points you need to focus on. I want to also point out some basic information that maybe you already know this, but maybe you forgot it. That a number, and I'm going to choose a number, I'm going to choose 3, let's say. 3 to the negative first power is 1 over 3. So that's why over here, e to the negative first power, e to the negative first power is 1 over e. And so here I called it e to the negative first, and here I called it 1 over e, but those are the same thing. That is 1 over e is 0.368. All right, let me talk a little bit about transformations. And these two places we're going to talk a little bit about transformations. Some transformations, let's take moving up, down, left, right. If you have e to the x with a big plus 4, where that big plus 4 is on the end, that's going to go up 4, right? However, this one, where is this one going to go? It's going to go right 3. So let me plot some of these on our graph. I'm going to count all the way up to at least 7. All right, I went up to 8 because that's how much I could fit. 7 or 8 would be enough here. Because let me start off with the parent function. The parent function, well, yeah, we can call it the parent function for e, would be this. And so I'm just going to put this on here. It starts here at 0, 1, as most of them do. The next point is 1e, so 1, 2, 3, a little bit less than 3. And like here. So I'm just going to make it a dotted line because that's not really part of my answer. But if this was my e to the x graph, if I move this up 4, I'm going to take each of those and move them up 4. Also, I'm going to move the asymptote up 4. So I have a horizontal asymptote right now at 0. I'm going to move that up 4. I'm going to do that first. So 1, 2, 3, 4. I'm going to put a horizontal asymptote here. Then my next point was a 0, 1. I'm going to move it up 4. 1, 2, 3, 4. I'm going to take this e, which is 2.718, and I'm going to move it up 4. And this point here, 1 over e, I'm going to move it up 4. And so this is my new function for g of x. It went up 4. And when it went up 4, the horizontal asymptote also moved up 4. If I look at h of x, that is moving right 3. If I move right 3, what about the horizontal asymptote? It doesn't move. I mean, it's sure you can scoot it over. That doesn't do anything, right? All we're going to do here is take each of these original points and move them over 3. And so this is my h of x. I just moved it over 3. So that's how you're going to do transformations of moving up, down, left, and right. On this one, let's talk about what are some other transformations. Like what if we're going to do a vertical stretch or a horizontal stretch or things like that. So let's do one where we do g of x is e to the 2x and talk about what that means. And then let's do one that is 2 times e to the x. All right, once again, I'm going to try to get a few more hash marks on here. 5 or 6 is probably good. I think I fit 7 just because that's the size I made them. But put some hash marks on your graph. And to graph this, we could think about a table of values. We can make a table of values, or you can think about a table of values in your head, whatever. But let's start with a 0. If we plugged in a 0 here, 2 times 0 is 0. Anything to the 0 power is 1. So this graph is still going to start at 0, 1. But then, if I plug in a 1, it's e to the second. And so that's 2.718 times 2.718. I'm going to go to my calculator and see what e to the second is. So I'm going to type in e to the second, and it's 7.389. Let's go back to our graph and see where that is. I had said to count to 5 or 6. It turns out this is a little over 7. So it's getting a little bit taller, right? So that is our g of x. But an important thing is it still has a point at 0, 1. And then this is going to be at 1, and then e to the 2x, well, e to the second, because our x was 1. And then over here, it's going to be a small fraction. I didn't bother to put it in my calculator. It's going to be a small decimal. Let's look at 2 times e to the x. Once again, we can make a table of values. You can just do this table of values in your head. I'm doing it on paper so that we can see what's going on, but really you could just do it in your head. If I plug in a 0, is that going to give me 1 like normal? It's not. It's going to give me a 2. And so that's one thing that you can look for again is where is that y-intercept? That gives me a 2. And then instead of e to the second, if I plug in a 1 here, it's going to give me 2 times e, and 2 times e is about 5.4, right? So when I graph that, I can go to 5.4. So 1, 2, 3, 4, 5 and a half. It's right about there. Okay, so this one is a little bit different. It also is a stretch in a way, but it's a little bit different of a stretch. And then the negative one is going to be 2 times that decimal I had up here, 3.68 or 0.368. So that's about 0.72. So this one's going to be about 0.72. So it's just not going to go as low in that first section. I'm going to correct mine. It's going to go to about 0.72 right about here. Now each of these still have a asymptote at 0. The asymptote is still, the horizontal asymptote is still at y equals 0. It's still going to be there. Okay, that's graphing. Again, for this unit, A, because we're not in school, but B, we're just not going to do a lot of graphing, but what you will need to do is maybe some matching. And this is how you're going to look. Well, these are the things you're going to look for. Look for that y-intercept. Where is the y-intercept? Look for where is the second point. Look for where is the horizontal asymptote. Those are some things to pay attention to, as well as your high-low rules and, how is it being stretched or where is it moving from there. The other thing to talk about today is how to do some of these things on your calculator or even in your head. So E really is just a number. It is a special number, but it's really just a number. And so when I do this, this is just going to be e to the 8th. Just like if that was an x, it'd be x to the 8th. So it's just e to the 8th. If you needed to get a decimal for it, you could put it in your calculator and you could get the decimal. But for this right now, e to the 8th is all it is. How about this fraction? Well, 12 over 4 reduces to 3. E to the 9th over e to the 7th reduces to e squared. So 3e squared is the answer. So it's just like a regular variable, even though it's not a variable, it's a constant, but you use the same rules. And same thing here. This is going to be 64e to the 10x power. You follow the same rules with exponents that we've been following on other things. And that's what these are asking you for. This is the answer we're looking for. It's not asking for a decimal approximation. You could do it on your calculator and you could get a decimal, but we don't need that for this. We just need this stuff. Okay, I do have summary lines here because it is the end of the week. So you might want to write some stuff down. You might write things down about graphing. You might write things down about we haven't done half-life yet. About exponential growth and decay, anything you might want to write down there in the summary. Those summary lines are for you so that you can remember some of the things that we've talked about the past couple of days.